Assalamu alaikum. I'm Saida Iman Fatma from Department Based Biotechnology. Today the topic of my presentation is peroxides and all types of peroxides. First, know that what are peroxides? Any of a class of chemical compounds in which two oxygen atoms are linked together by a single covalent bond are peroxides. The OO group in the structure of peroxide is called the peroxide group or peroxo group. Now the question arises, how peroxides are formed. A wide variety of organic compounds spontaneously form peroxides by a free radical reaction of the hydrocarbon with the molecular oxygen. The organic compounds which reacts with the oxygen to form peroxides which can explode from impact, heat or friction are called peroxide formers, and these are ethers, acetals and ketals, especially cyclic ethers and aldehydes including acetaldehyde and benzaldehyde. How can we know that a peroxide is formed? Few signs shows the formation of peroxides. These are crystallization, discoloration and stratification. Now we are going to talk about the classification of peroxides. The most common peroxide is hydrogen peroxide, informally known as peroxide. Aside from hydrogen peroxides, some other major classes of peroxides are main group peroxides that contains the compound with the linkage of EOOE group, that is main group element, and the metal peroxides which includes barium, sodium and zinc peroxides. The last one is organic peroxides which contains the compound with the linkage of COOC or COOH bond group. The main question is the difference between water and peroxides. Hydrogen peroxide is a colorless liquid that resembles water in many respects, but they are not similar. There are quite differences between them. The physical properties of peroxides are quite similar to water except that the peroxides are 40% denser than water. The main difference between hydrogen peroxide and water is its chemical behavior. The single bond between the two oxygen atoms is weak so that H2O2 readily separates into either H and HO2 or 2OH. The resulting species are free radicals, which means that they are very reactive, and this makes H2O2 a very powerful oxidizing agent. Now we're going to talk about the preparation of hydrogen peroxides. How hydrogen peroxide is prepared? It is prepared by two methods. The first one is barium peroxides. It is method for laboratory preparation of hydrogen peroxide. In this, a hydrated barium peroxide is used to prepare hydrogen peroxide. And the second method is sodium peroxide, in which sodium peroxide is gradually dissolved into the dilute solution of sulfuric acid. H2O2 is explosive in nature, so we use cold sulfuric acid. On reacting these two, we get crystals of sodium sulfide and a 30% solution of hydrogen peroxide, which we can perform vacuum distillation on the solution to get pure hydrogen peroxide. Now we are going to talk about the properties of hydrogen peroxides. Hydrogen peroxide is an almost clear pale blue liquid in its pure state. It has an odor similar to that of nitric acid. Hydrogen peroxide has a viscosity higher than water, that is, it is 40% denser in water. The pure concentrated form boils around 150 degrees Celsius, which means that it undergoes thermal decomposition and has an explosive reaction. It is miscible in water, that is, it forms a homogeneous solution when mixed with the water. it is acidic in nature, and H2O2 is a very strong oxidizing agent. The peroxide has following uses, which are: hydrogen peroxide is used as an antiseptic for minor cuts, bruises, laceration, and it is extensively used for bleaching purposes and used in air pollution control to treat effluents from industrial waste. It is also used in the restoration of aerobic condition to sewage and industrial waste materials. Now we are going to talk about the preparation of barium peroxide. Barium peroxides can be made by the reversible reaction of O2 with the barium oxide. The properties of barium peroxides are following. It is an organic compound. It is white, cream or grayish powder in appearance. When anhydrous barium peroxide, it is gray-white crystalline in appearance, and the colorless solid in appearance is octahydrate. It is odorless. It may or may not be soluble in water, such that the anhydrous is not soluble in water while the octahydrate is soluble in water. It dissolves with decomposition in acid. The uses of barium peroxides. These are the few uses of barium peroxides: as it is used as a bleaching agent and in the making of hydrogen peroxide and aluminum welding and textile dyeing. Now we are going to talk about the preparation of sodium peroxide. Sodium peroxide can also formed by two methods, which is from hydrogen peroxide and from ozone. From hydrogen peroxide, it is prepared by treating sodium hydroxide with hydrogen peroxide at 130 to 200 degrees Celsius temperature. And from ozone, it may also be produced by passing ozone gas over solid sodium iodide inside a platinum or palladium tube. The ozone oxidizes the sodium to form sodium peroxide. The iodine can be sublimed by mild heating, and the platinum catalyzes the reaction and is not attacked by sodium peroxide. Now lastly we are going to discuss the properties of sodium peroxides. It appears as a yellow-white to yellow granular solid, and it is soluble in acid and insoluble in alkali. It reacts with water, and it is a strong oxidizing agent and is stable at ambient temperature. These are the few uses of sodium peroxide. Sodium peroxide was used to bleach wood pulp for the production of paper and textiles. Now it is mainly used for specialized laboratory operations. Example given: the extraction of minerals from various ores. It is used as an oxidizing agent. It is also used as an oxygen source by reacting with carbon dioxide to produce oxygen and sodium carbonate. Now we are going to talk about the explosive characteristics of peroxides. Hydrogen peroxides, either in pure or diluted form, may pose several risks. The main one being that it forms explosive mixture upon contact with organic compounds. When hydrogen peroxide is boiled around 150 degrees Celsius, it undergoes thermal decomposition and has an explosive reaction. It is only a theoretical assumption. This is because it explodes before reaching its boiling point. Now I'm going to tell you about the applications of peroxides. Peroxides have variety of application areas. The first one is chemical synthesis. In this field, it has found its use as an oxidizing agent because of its low molecular weight. And the second one is aseptic packaging. Hydrogen peroxide is a highly microbiologically safe reagent. Therefore, it is used as a sterilizing agent for the internal aseptic zones of the manufacturing machines and the surface of the packaging material that will be in contact with the food. Cosmetics and medicines. The peroxide's oxidizing property makes it suitable for use in the cosmetics and medical fields as a disinfectant and a bleaching agent. For instance, in cosmetics, it is used as an antimicrobial agent during oxidative hair dyeing, while in medicines, it increases the whiteness of teeth by oxygenating stains. Electronic industry. In this field, it finds its use as an oxidizing and a cleaning agent. The manufacturing process of semiconductors uses high-quality electronic-grade hydrogen peroxide as an oxidizing and cleaning agent. Environment. Hydrogen peroxide is environmentally and ecologically friendly, hence it finds use in a variety of applications related to the environment, that is in an advanced oxidation process. Now, food processing. In the food processing industry, hydrogen peroxide is the most commonly used bleaching agent, where it finds its use as a peroxygen reagent. Natural oils, natural sugars, waxes, starch, and gums are some of the compounds bleached using peroxides. In mining, the mining industry uses hydrogen peroxides both as an oxygen source and as an oxidizing agent. For instance, it is used in gold and uranium production processes, in concentrates preparation and ore leaching. In pulp and paper industry, it is used as a versatile bleaching agent, especially in chemical bleaching sequences. In mechanical pulp bleaching, it is used as the core bleaching agent. In paper recycling plants, it finds its application as a de-inking agent. In textile industry, it is the prime bleaching agent in natural and synthetic fibers treatment, which include wool, linen, cotton, silk, and rayon. It gives the fibers a high degree of brightness while at the same time preserving their mechanical properties. In transportation industry, it is used as a propellant, for instance, hypergolic bipropellant engines, which are used in monopropellant systems, and launch vehicles use high concentration hydrogen peroxide. Where peroxides has so many benefits, it also has some side effects. The use of peroxides causes effects such as the following: toxicity or fatality when inhaled or swallowed, a potentially high risk of cancer, damage to your eyes, internal organ damage, itching, irritation. In my opinion, peroxides, mainly hydrogen peroxide, is one of the major members of reactive oxygen species and plays an essential role as a beneficial signaling agent or a toxic hazard in physiological and pathological processes. This was my presentation, and I hope you understood all the points which are discussed in it. Thank you so much.